Just now doing math. Oh my lord. It's ridiculous. Absolutely ridiculous. Help, please. Help me get there.
So add 5.2.
Do what?
Add 5.2.
Okay.
And then you get 735. And then this 6.7J equals 4.33J plus 735. And then you subtract 1.33J from both sides. And you get 2.45. And then divide 2.45 from both sides, and you get J equals 3.
Now what?
That's it. And then you check again.
I don't know what 6.78 times 3 is. Not subtracted by 5.2. I don't know what 4.33 times 3 and then add 215 is.
It's 34.
But you plug it in all at once.
Okay.
15.14. Yeah, and the same one is 5.14, 15.14.
I'm sorry, I thought the images got super
Okay. Next. What's the mean? How do you find the mean? What's another word for mean? How do you find the median?
Just the middle, but you add a 10 and
But why? Why do we add? Yeah, that would work too, but why? Yeah. Okay. At least we can do math. I'll give you that. May not be as fast as I'd like today, but it is math. Okay, so we've been talking about parabolas and quadratic functions. My learning target's kind of stinky. I can graph quadratic functions using different forms of quadratic equations, aka Miss Compton is lazy. We're going to see how to graph from standard, intercept, and vertex form. Graph from 3 different forms because there can be 3 different forms of this equation. What's standard form? You know standard form. What's standard form?
Plus t squared.
That's the Pythagorean here.
Y equals, that's not standard form. That's what, A plus B.
Oh yeah, that's right.
Is that right?
No. What are we talking about again? What kind of functions are we talking about again? Tell me the difference between a quadratic and a linear. What's the difference? That is the difference between their graphs. I like the motions. What's the difference between their equations? What's different about the terms? Because that, my friend, is linear. What is a quadratic? What's a quadratic equation? How do you know you have a quadratic and not a linear?
Is there a Y in there?
Oh my gosh, no. Please. I mean, there could be. There is a y equals. I mean, my gosh, we can read better than most people. Plus, you know what you've been doing lately. What's missing from what I've written at the top than what you've been doing lately? Say it again.
There's a third value. It's instead of it
Squared.
there's this split.
Please fix it then. What should I have on the screen then? Then what?
X.
Bless you. We've been using this for forever. We've been factoring. If A was 1, it was easy factoring. If A was bigger than 1, we used an into star. Oh my God, we've stared at this for like, it was before spring break. It's probably February. I've been staring at this for a while. We forgot about it? Oh Lord. Oh Lord. Okay, so how to graph in standard form? That is a good question. Okay, first let's identify the A, B, and C of our first example. By the way, I'm going to work every other example. Yours is the others. What's the A, B, and C of our first example? Okay, A is, tell me slowly again. A is,
X squared. And then B is -2x. And C is negative.
there's some things wrong with what she's saying. Can someone help her fix it? She said A is x squared.
A is 1.
A is 1. What is B? -2. And what is C? She had that right all along. Okay, A, B, and C. We at least need to know them. Okay, so you're given this equation. Somehow you want to make a graph. You're not getting to use Desmos. You're not getting to use your graphing calculator. We're just going to have to figure it out with our brains and apparently this equation. What's the first thing we know for sure about this parabola? I know it opens. Is it going to be a happy face or is it going to be a sad face? How do you know if it's happy or sad? Negative where?
Where it crosses the line.
How do you know, like, this equation is a sad face or this equation is a happy face? How do you know opens up, opens down? You've been graphing these for a couple days now. This looks really similar to one you were working yesterday because I can factor that, and I'm sure we'll have to in a few minutes. Because where have you been my whole life? It opens up because the x squared is positive, or if we're using those A's, B's, and C's, because A is bigger than 0. Is opens up a happy face or a sad face? Happy face. Opens up would mean we're smiling. John David is right. So we look at that A. All of the ones you were doing yesterday, I believe, were all a positive A, so they were all opening up. Okay, so I'm going to help you fill in some stuff. You're still going to have to graph it yourself. Looking at example 2, how should it open?
A is smaller than
So A is less than 0. So how does it open?
down.
So it's going to end up being a frowny face. Okay, so John David's helped us with that mystery. Is it happy or sad? What else do we need to know about a parabola in order to graph it? We could use, those roots sure would help. That is never a bad idea. And we could continue on with that factoring thing we were doing yesterday. What adds to -2 multiplies to -3. Yeah, I know it's -3 and 1. So, I'm going to use that in a second. What else do we need to know how to graph it? But I'll go ahead and write that because she is right. The roots end up being, what'd you say? Okay, it ends up being the opposite sign. So, because remember we were doing that form yesterday where it was x minus r1 and x minus r2. So it ends up being, you said -3, it'll actually have it at +3. You said +1, it'll end up being -1. It ends up being the opposite signs. But that's just a side. She's just being smart for that. I didn't even write it in the main little area. Still got some other stuff to figure out. What else do we want to know besides the roots? We would love to know that vertex. What else would we like to know besides the vertex? What also leads you to the vertex? Axis of symmetry. So you'd say, Ms. Compton, is there an easy way to find that axis of symmetry? And there is. There is actually an equation that if you memorize this equation, you will always be able to find the axis of symmetry of your parabola. It is -b over 2a. -b over 2a. I have no idea why I put that a in parentheses. Honestly, no clue. If I could undo it, I would. So in our case, -b is going to be a -2 over 2a. A is 1. So we end up having a +2 over 2. What does that end up reducing to? 1. So it has an axis of symmetry at 1. And if we're being real specific, our axis of symmetry is at x equals 1. So I could go ahead and draw that in. I will at least draw that. Axis of symmetry. And Kiana's right. It does have roots at 1, 2, 3, and -1. But in a second, I'm going to show you a trick. So does Kiana always have to find the roots to graph it correctly? No. Does knowing the roots give you the answers, though, to most questions? Yes. Okay, so we found the axis of symmetry. We found the roots. What else do we need to find? It sure would be nice to find that vertex. Sure would be nice to find that vertex. We took some notes the other day about life. And somehow the axis of symmetry and the vertex are tied together. How is that?
Because once you graph the roots, you have to find the center to reach.
There's only one point on the parabola that touches the axis of symmetry. What is that one point? The vertex. It won't work. It's broken. That's why it's on the desk. I gotta fix it. If you want to fix it, be great. Okay, so what we could do, we know the x value of the vertex. We know it's 1 something or other. We could plug it back in that equation. And so x is 1. So 1 squared minus 2 times 1 minus 3. We could do that. So 1 minus 2 minus 3. That ends up being -5. I don't know. What does that end up being? -4? That's what I thought. 1 minus 5, which is negative 4. So my vertex is actually at 1, negative 4. So I go over to 1, I go down 1, 2, 3, 4. 1, negative 4. Or, let's say Kiana doesn't want to do this. She's for sure, Kiana has no options. She needs to know if it opens up or down. She needs to at least know where that axis of symmetry is. But she can possibly get away from knowing the vertex if she at least knows that y-intercept of this graph, which is why my final statement would be the y-intercept is when x is what? What is x when we're looking for the y-intercept? Okay, so I'm looking to see where it crosses the y-axis. And if I'm looking for an ordered pair, does it cross here? That would be 0, negative 1. Does it cross here? That's 0, negative 2. That's 0, negative 3. That's 0, negative 4. We know it crosses somewhere in there. What number did I start off with every time? 0. So we could plug in a 0 instead of plugging in a 1 if we're trying to figure out that y-intercept. We'd plug in x being 0, so we would have y equals 0 squared minus 2 times 0 minus 3, but John David's smart. He realizes if I plug in a 0, those two go away. The intercept is at negative 3. So I already knew it was going to cross at negative 3. And I lied. I'm going to help you do the next one too. I'm nice today. Sometimes. John David already helped us figure out it opens down. Can you tell me the axis of symmetry?
Do I still start off positive?
Can someone tell me the axis of symmetry? I told you what equation to use for axis of symmetry. Still going to work here. Still going to be negative b over 2a.
That's all that. Then negative 4.
Okay, so you did negative 4 over 2 times negative 1, and you got 4?
2.
And I'm with John David. I just got 2. So my axis of symmetry is a 2. I could factor it, but Lord knows I start getting confused when that negative's in front, so I'm gonna leave that alone for a few minutes. I can figure out, since I know that axis of symmetry, I can figure out the vertex. I didn't label that before. I can figure out that vertex. So everywhere in my equation that I see an x, I'll put in my 2.
What's the vertex formula?
It literally is, if you know the axis of symmetry, plug that in for the x into your given equation. What did you get when you plugged it in?
Negative 3.
You got negative 4 plus 8 minus 3. So it ends up being 8 minus 7, which is just 1. So my vertex should be at 2, 1. And then maybe it might be easy to figure out that y-intercept, because all you have to do is plug in a 0 for the x values in the equation. So where would my y-intercept happen? You're smart. It doesn't take that long. Where's the y-intercept at? It's a -3. And do you actually have to go plug in zeros and write that down on your paper? No. That would go away. That would go away. It ends up being the last term every time. It ends up being C every time. Okay, so my y-intercept is at -3, 1, 2, 3. And this looks right because, I mean, it was supposed to be a sad face. It's starting to look kind of sad. And if I'm being real smart, like if I know that point's there, don't I know it has a twin over here? Like if this one was 2 to the left, don't I know that one's 2 to the right? Or heck, even back on the first one. This one was 1 to the left, so my other is 1 to the right. Because a parabola, that's what's so cool about it, is that it's symmetric.
You don't want us to like connect it anymore.
Oh, we're going to. And now that I've said all those things, and possibly explained 1,000 things all at once, and you're like, Ms. Collins, could you not explain any more about parabolas today? I'm going to show you a trick. It depends on your A value. If your A value is 1, it will always work like this. If your A value is something other than 1, that means your graph has either been stretched, we discussed whole numbers end up making us fat, and then fractions make us fat, whole numbers end up making us skinny. But if your A is 1, it will always work like this. If you know your vertex, it's always over 1 up 1, over 2 up 4, over 3 up 9. Why is that? Because those are perfect squares. 1 squared, 2 squared is 4, 3 squared is 9. So if I wanted to go even further, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It ends up being that way every time. If John David had room, he could go over 4 up 16, over 5 up 25. It keeps on happening. You may finally connect the dots. But we got all of this information from just that equation. We didn't ask Desmos. We connected those dots ugly, Miss Compton. We didn't ask Desmos. We did not pass go. We did not collect $200. We did that all on our own. So on this other one, since A is still 1, it ends up being over 1 down 1, over 2 down 4. There's not enough room to go over 3 down 9. Okay, so what I want you to do, because I get my life is sad and I'm almost out of time, what I want you to do is, I'm going to give you 2 to do yourself. And you're going to be annoyed because they're ones you've recently seen, but you don't have these anymore either. The 2 I need you to do, I'm going to put on the bottom of my flap so I recall which 2. I need you to do what we just did. Figure out the graph by finding either the roots, the axis of symmetry, the vertex, the different pieces we were finding then. For, let's say, y equals x squared minus 6x minus 7. Wonder where I've seen that before. And 2y equals x squared minus 9x plus 20. I know it's annoying because you just dealt with those 2 equations. You've already graphed those 2 on Desmos before. But this time, it's just you. You figure out, if you want to find the roots, great. But you find that axis of symmetry,